Welcome to Econ 317. In this instruction video, we will go over an example of price consumption curve. So the price consumption curve is the locus of all combinations of the goods which a consumer chooses while maximizing his or her utility function given the prices of the prices of the goods and the income at hand. So we want to draw the graph of price consumption curve. In order to do that, we will assume there are only two goods. So good X, its price is what we will change. I will write it as P of X. Good Y, and this price I will assume to be constant. We will change only one of the parameters at a time. So dollar per unit. And then we will also not change the income, which I will assume I to be fixed at $100. For the price consumption curve, I also need the choice made by the consumer while maximizing the utility. So I need to write down the utility function of the two goods. Let's assume the Leontief utility function, which is the minimum of 4x and 5y. Just to draw an example of an indifference curve for this utility function, I will assume x on the horizontal axis, y on the vertical axis. And let's say I want to draw indifference curve for the utility level u of xy to be equal to 20. In that case, I will have the consumption bundle 5 and 4, which will generate indifference utility level of 20 units. So the Leontief indifference curves look like the L shaped. So no, it should not go beyond, it should be from here on, and that's an indifference curve. I will write it as u of xy equal to 20. So this is the typical utility indifference curve for Leontief utility. Instead of solving for the optimal consumption bundle, what I am going to do is I will write down the solution, because our goal is to draw the price consumption curve rather than do the optimization exercise. So let me write the optimal consumption bundle in this case to be 500 over 5p plus 4 y star to be 400 over 5p plus 4, where what I have done is I have assumed the price of good x, which I had written as p subscript x before, to be p itself, because this is the only variable which we will be changing. Given this, now I can find out the optimal consumption bundle chosen by the consumer when price of good x, which is p here, changes, retaining the price of good y at $1 per unit and the income $100. And this is then we will plot the combinations of x star and y star to obtain the price consumption curve. So let's create a table where I have price of good x, then the quantity x star, quantity y star, which is the choice made by the consumer in response to the given price. So I start with price of good x to be $0.8 per unit. You can plug this value in the expression written above. You will be able to find out x star turns out to be 500 over 8. Y star turns out to be 400 over 8. If I increase the price from 0.8 to 1.2, the quantity x star would turn out to be 50. y star would turn out to be 40. Each one of these numbers I am obtaining by plugging in value of p in the expression for x star and y star. I will write at least few more. So I take price of good x to be 1.6. The values of x star and y star turn out to be 500 over 12 and 400 over 12. I go little further. I take the price of good x to be $2 per unit. My answers turn out to be 500 over 14, 400 over 14, and then maybe one more, 2.4. Price of good x is 2.4. The quantity chosen, 500 over 16, 400 over 16. And so now I have got enough information to be able to draw the price consumption curve. Again, as I have said before, price consumption curve is the locus of the choices made by the consumer when I have changed price of only one good. So I have y on the vertical axis, x on the horizontal axis, and then I want to draw the price consumption curve. We will like to show it as the optimal choice made by the consumer when I am changing the budget set available to the consumer. So let's start with the vertical intercept. Since we are not changing the price of good y, also we are not changing the income, the vertical intercept would turn out to be income over the price of good y, 100 over 1. So this is 100. This is the information which never changes. And then I will draw some of the budget lines. So let's say this is the budget line when price of good x is 0.8, price of good x goes down, goes up, the budget set shrinks inward. These are the budget sets we are facing as we keep changing the price of good x, rather as we keep increasing the price of good x. And if you see the relationship between x star and y star, which was, I will rewrite it here again, 5p plus 4, y star 400, 5p plus 4, we can see y star is 4/5 of x star. So that's the relationship we got given this in this utility function for the optimal consumption bundle, which is a straight line, positive slope 0.8. So all the optimal choices made by the consumer would fall on this straight line. So for the budget set, which is the outermost, where the horizontal intercept should be 125. The choice made by the consumer is this point. So I will draw the indifference curve passing through this point. You will notice at every indifference curve, the optimal choice is such that we are always at the point of the kink where there is change in slope. So this way I go down little further here every time. So these are the indifference curves which give us the optimal choice. Maybe I should write down, I should point out the choices by giving them a name. So let's say I will call this the first one as point A, the second one as point B, C, D, E, just to denote them on the graph. So now I have this one as point A, the second one as point B, third one as point C, I go down further, I get point D here, point E here, and so this is the price consumption curve. The straight line with the slope of 4/5 is the price consumption curve. I can use this information also to draw the demand curve for good X. Rather, we will draw the inverse demand curve, but we will first point out, list down the choices made by the consumer when the only parameter that changes is price of good X, price of good Y, and income remains same. So let's have P of X. Now I'll call it as P as before, and then I have the choice made by the consumer of the quantity of good X. So we will list down. This is from the previous table, but I will write it once more because this is the information which I am going to plot. When price of good X is 0.8, the quantity chosen 500 over 8. 1.2, this turns out to be 50. 1.6 turns out to be 500 over 12. 2 turns out to be 500 over 14. We could have plotted, listed down some more. Maybe I will write down at least the one we had written before, 2.4, 500 over 16. And now we can plot these for the inverse demand function for the good X. So what I am going to do is now I will have price of good X on the vertical axis, X quantity of good X on the horizontal axis, and we now have a graph which should look non-linear. When price is 0.8, the quantity I find is 500 over 8. Price goes to 1.2, the quantity I find is 50. 1.6, the quantity is 500 over 12. And this shows us the downward sloping demand for good X. I can write down the expression for this equation as well, which we had seen before, is X star equal to 500 over 5P plus 4. As you can see, when the price of good X increases, P is in the denominator increases, there is no change in the numerator, so the value of X star would go down. And that's the downward sloping demand for the good X. This is also a good example to see that for this utility function or for this preference, the inverse demand function is not a straight line. And this is a good point to stop.